Problem 7 asks, which rule can be used to determine the value of the nth figure in the sequence below? So we know the value for figure 1, the position in the sequence is n equals 1. We know the value is 2 because there are 2 squares. Position 2 in the sequence corresponds to figure 2, and there are 5 squares. Position 3 corresponds to figure 3, and there are 8 squares. And then position 4 corresponds to figure 4, and there are 11 squares. So there's 2 different ways to approach this. First thing we could do is see how this sequence is changing each time. It's increasing by 3. From here to here it's increasing by 3, and from here to here it's increasing by 3. So we know from all the practice we did in class that if you have an arithmetic sequence like this, that it's increasing by the same amount each time, you can take that number and multiply it by n to start writing your rule. That won't necessarily be the whole rule. We may need to add or subtract something from that, but we can start our rule with 3n. Then we look at n equals 1. For n equals 1, 3n would equal 3 times n, or 3 times 1, which is 3. But our term isn't 3 when n equals 1, it's 2. So how do I have to change our rule 3n to get 2? We have to subtract 1. 3 minus 1 would be 2. So 3n minus 1. And that corresponds to answer choice B, but let's check it just to make sure. Let's take another value of n. Let's take 4 and try it with 3n minus 1. 3n means 3 times n, so 3 times n, but n is 4. 3 times 4 minus 1. 3 times 4 is 12. 12 minus 1 is 11. So that checks out, so that is the correct rule. Another way you could do this problem is you could take different values of n and try the different answer choices. If n equals 1, answer choice A would be 1 squared minus 1. 1 times 1 is 1, and 1 minus 1 is 0. That's one way to rule out answer choice A because the first term is not 0. We already know it works for B. If I try n equals 1 for the rule in answer choice C, we'd have 1 plus 3. That's 4, not 2. So we can rule that out. And if we try n equals 1 for 2n plus 3, that's 2 times 1 plus 3. That's 2 plus 3 or 5. Oops. 2 plus 3 or 5, and that's not 2, so we can rule that out. So if you're given answer choices, rules, you can try them with different values of n. The only tricky part is you may need to try more than one value of n to narrow it down to the final answer. Okay, I put this golden ticket in a review video for the last unit test, but I don't think anyone noticed it, or there weren't a lot of people viewing those review videos because people were very well prepared for that test anyway. Here's what you need to do to win this golden ticket. Solve this problem and move this out of the way. It says a recipe requires 3/4 of a dozen eggs. If you need to double this recipe but already have 2/3 of a dozen, what fraction of a dozen will you need? So be the first one to bring me the correct answer to that problem and show your work, and first person with the correct answer will win the golden ticket. Anybody that brings me a correct answer after the first person will win 10 tickets for the weekly drawing, and anybody who brings me an incorrect answer but shows me that they tried to solve the golden ticket will win 5 tickets for the weekly drawing. Okay, we'll pick up the review with problem 8 on the next video.